In this video, we're digging into a very important concept that most students don't get it right: the normal force. This concept shows up in later chapters, such as the circular motion and the gravitational field. Make sure you get it right before you proceed to more difficult chapters. All right, take a moment, pause the video, read the questions, and sketch a quick free body diagram. When you're ready, hit play. Let's pull the key information from the question. The first piece is the weight of 600 Newton. This is quite straightforward. This is a force acting on the center of the person by the gravitational field, and it is pointing downwards. All right. The second piece of information is a scale reads 900 Newton, and it tells us the normal force. Think of the normal force as the support pushing force you get from whatever surface you're standing on. Here, the person is standing on the scale, so the scale itself is the surface doing the pushing. It presses upward on the person's feet with a force of 900 Newton, label as N. So in one sentence, the scale reading of 900 Newton is the normal force acting on the person. Let's draw a free body diagram. The small dot represents the person. The upwards normal force is 900, and the downward weight is 600 Newton. Okay, let's build the logic chain. The first step is to identify individual forces, and we've done that. Then we calculate the resultant force. Finally, we apply Newton's second law, F equals ma. Now, quick warning, never plug individual forces into the equation, and in this case, 600 Newton or 900 Newton. The right way to do this is to calculate resultant force on the object first, then plug it into F equals ma. All right, pause here if you'd like to try it on your own. Welcome back. Let's work step by step. First, let's define upwards at the positive direction. It is a good habit to define positive direction when you are handling vectors. Then let's use the individual force to calculate the resultant force. As a normal force is upwards, so it's positive, and weight is downwards, so it's negative. Plug in numbers, and the resultant force is 300 newtons. Now we have the resultant force. We can plug it into F equals ma. We don't have m. What is the mass of the person? Take a moment to read through the question again and think about this. Do you get it? We know that the weight of the person is 600 Newton. So we can calculate mass. Mass equals to weight divided by g. Sub this into F equals ma, and we plug into numbers. And finally, we get the result. 4.905. And because we get a positive number for acceleration, and as we define upwards as the positive direction, so the acceleration is upwards. The answer is D. Let's do a quick recap. First of all, to use F equals to ma, you need to first identify the individual forces, then figure out the resultant force. Then you can plug the resultant force into F equals to ma. Another key takeaway is the scale shows the normal force, which is like an upward support force acting on the person. Please feel free to post any questions in the comments. I'll get back to you ASAP.